Hello, everyone. This is Miss Kanyambu from Grace Nursing Tuition Center, and today we are going to look at fetal circulation. So, circulation literally is talking about how blood moves in the body, and the way blood moves in the body once the baby gets born is actually different from the way blood moves in the fetus. So, the fetus is actually life in utero. So we are going to look at the special mechanism that goes on in the transportation of blood. So the fetal circulation is actually a component under the circulatory system. And the main function of the circulatory system is to transport blood throughout the body. Yes. And today we're specifically going to look at the blood circulation in a fetus. This is life in utero. It undergoes a special mechanism, yes. And then we know that the circulatory system carries blood, and blood is a major component. Even like an adult, you need blood because it is in the blood it's the blood that carries the oxygen, and then it's the blood that carries the various nutrients that the cells that will be in need of by the cells in order to carry out their usual functions. Yes, so today we're going to look at the fetal circulation, and this is actually very important because you know that the fetus is actually undergoing massive organ development, and it needs the blood for oxygen and the necessary nutrients so that it can go through the appropriate development, so that it can the nutrients and the oxygen can aid into the development of the fetus. So this is the main diagram that we're going to use in order to illustrate how blood is actually moving in the fetus. Yes. So the first and foremost, we're going to look at the normal fetal circulation. The normal fetal circulation, and as you can see there, that is the placenta. So the placenta is attached to the mother in the uterus. That is the placenta. And then if you look at this red cord here, that is the umbilical vein. And the purple cord there, that is the umbilical artery. So we've got literally three blood vessels. Two umbilical arteries and one umbilical vein. Initially, there are actually two umbilical veins as well, but the right umbilical vein tends to degenerate. Therefore, we only remain with one umbilical vein. So we've got the two umbilical arteries and one umbilical vein. So the umbilical vein in this case transports or carries blood and nutrients, blood which is highly oxygenated, carrying about 80% of oxygen. So blood is moving from the placenta to the fetus via the umbilical vein. So the umbilical vein is carrying highly oxygenated blood with other nutrients from the placenta to the fetus, while the umbilical artery is carrying less oxygenated blood with waste product from the fetus to the placenta, to the circulatory system of the mother through the placenta. So those are the three blood vessels that are in the fetal circulation. So the umbilical vein, 1 and 2 umbilical arteries. So what happens is this: when blood moves from the placenta via the umbilical vein to the fetus, the blood will first go to the liver. So much of this blood, less of this blood is going to go to supply the hepatic renal system, which is the liver, through the vessels we're calling the sinusoid. So once blood enters from the umbilical vein, it goes to the fetus. The first place it will go to is the liver. So a little amount of this blood is actually going to go to is going to supply the hepatic renal system, which is the liver, via the sinusoids, while much of this blood is actually going to go through the ductus venosus. So the ductus venosus is the first shunt that we have there, or the first opening that we have there. So the ductus venosus is communicating between the umbilical venous blood and the inferior vena cava. So this is how the blood is moving from the placenta via the umbilical vein to the liver, right? Much of the little of this blood goes to supply the hepatic renal system, which is the liver. Then much of this blood passes through the venous the ductus venosus to the inferior vena cava. So the ductus venosus is the first shunt that is communicating between the umbilical venous blood and the inferior vena cava. So once blood, so much of the blood is going to go now in the inferior vena cava, and then this blood, remember, it is highly oxygenated, carrying about 80% of what, of oxygen. So it is in the inferior vena cava. So from the inferior vena cava, it goes to the what, to the right atrium. That is the right atrium there. Now the thing is that between the right atrium here and the left atrium there is a shunt, an opening that we're calling the what, the foramen ovale. So the right atrium and the left atrium, there's an opening there that is communicating between the right atrium and the left atrium, and that opening is what we're calling the foramen ovale. So blood is moving from the inferior vena cava into the right atrium. From the right atrium, it goes to the left atrium through the shunt what is called foramen ovale. So from the right atrium to the left atrium through the foramen ovale, the blood moves to the right ventricle, to the left ventricle. From the left ventricle, the blood goes to the aorta. Let me just repeat that. Blood is coming from the placenta via the umbilical vein to the liver, from the liver through the ductus venosus to the inferior vena cava. From the inferior vena cava, it goes to the right atrium. From the right atrium, it goes to the left atrium via a shunt known as foramen ovale. From the left atrium, it goes to the left ventricle. From the left ventricle, it goes to the what? To the aorta. Yes. Now the thing is that there is blood coming from the superior vena cava. You know that the blood actually is coming from the rest part of the body. There's blood coming from the inferior vena cava, from the rest part of the body, and there's blood coming from the superior vena cava, and this blood is less oxygenated, right? Yes. So the superior vena cava blood will come from the superior vena cava. It will go to the what? To the right atrium. From the right atrium, blood is not going to go through the foramen ovale, but blood, it is going to go down the right ventricle. The blood that was coming from the inferior vena cava, it went into the right atrium, then it went through the foramen ovale to the left atrium, then to the left ventricle, then to the aorta. But the blood that is coming from the superior vena cava, it is coming in the right atrium, then down the right ventricle, then it goes to the pulmonary artery. Now the thing is that just there. Now the thing is that from the pulmonary artery, you know that the normal circulation, blood needs to go down to the lungs. But in this case, the lungs are immature, as you know that the fetus is actually going under organ development. So the lungs are immature and they're collapsed. Therefore, not much of this blood should go to the lungs. No wonder much of this blood actually went through the foramen ovale to the right atrium. No wonder we have a little amount of blood coming from the from the right atrium to the right ventricle, going to the pulmonary artery. So much of this blood here will not proceed to go to the lungs, because the lungs are immature, they are collapsed, and there is resistance here because they are collapsed. So much of this blood is going to go through this shunt, which we are calling the ductus arteriosus. So remember, we talked about the ductus venosus, which is communicating between the umbilical venous blood and the inferior vena cava. But the ductus arteriosus is actually communicating between the pulmonary arterial system and the aorta. So the blood in the pulmonary artery is not much of it is not going to proceed to go to the lungs, because the lungs are inflamed. They are collapsed. Therefore, there is high resistance. The blood cannot go that side. So much of this blood is actually going to go through this shunt we're calling the ductus arteriosus into the aorta, right? And then little of this blood will actually proceed to go to the lungs. Then from the lungs to go through the pulmonary vein. Then from the pulmonary vein to go into the right atrium. From the right atrium, left atrium. From the left atrium, it will go to the left ventricle. From the left ventricle, it will now go to the aorta. So you've seen the way the blood is moving. So we're in the aorta. So let me just go back a bit. The blood coming from the placenta via the umbilical vein to the liver. From the liver via the ductus venosus to the inferior vena cava. From the inferior vena cava, it goes to the right atrium. From the right atrium, the blood goes to the left atrium through the shunt known as the foramen ovale. from the left atrium, the blood goes to the left atrium. From the left ventricle rather. From the left ventricle, the blood goes to the aorta. And then there is blood coming from the superior vena cava. So blood is coming from the superior vena cava. It goes to the right atrium. From the right atrium, blood will proceed to the right ventricle. From the right ventricle, the blood will go to the pulmonary artery. Then in the pulmonary artery, much of the blood is going to go via the ductus arteriosus to the aorta. A little of this blood will proceed to go to the lungs, and then from the lungs to go via the pulmonary vein into the left atrium. From the left atrium, it will go to the left ventricle. From the left ventricle, now it will go to the aorta. So that is how blood is moving. And then blood is now in the aorta. And then you need to remember that the blood that was coming was what? Highly oxygenated, carrying about 80% of oxygen. So as it is moving in these places, it's actually becoming lesser oxygenated. So the blood in the aorta now, in this aorta here, it's now more like lesser oxygenated than it was. So blood will now move from the aorta, descending down the aorta. Right? So once it reaches down the aorta, these are what? The umbilical arteries. Blood will go through the umbilical arteries. And now the oxygen here, it's about 58%. So the oxygen concentration has actually reduced because it's been used, it's being used up. It has been used up by the liver and other organs as well for their development. So blood will move back down the umbilical arteries to the placenta. And then this blood has less oxygen and it's got some waste products. So that is how blood actually moves in the fetus. We're going to say that again. Blood from the placenta via the umbilical vein to the liver. From the liver to the inferior vena cava through the ductus venosus, the first shunt. From the inferior vena cava, it goes to the right atrium. From the right atrium, it goes to the left atrium through the foramen ovale. From the left atrium, the blood goes to the left ventricle. From the left ventricle, the blood goes to the aorta. And then blood from the superior vena cava goes in the right atrium. From the right atrium, it goes to the right ventricle. From the right ventricle, it goes to the pulmonary artery. From the pulmonary artery, much of the blood is actually going to go to the aorta via the ductus venosus, the third shunt. And then little of the blood will proceed to go to the lungs, and then from the lungs via the pulmonary vein into the left atrium, from the left atrium into the left ventricle, then it goes to the aorta. And then from the aorta, the blood descends down the aorta, then back to the what? To these two umbilical arteries and back to the placenta to be excreted in the mother's circulatory system. So that is how blood moves in the fetus. Those are the steps or the routes the blood actually takes, right? I hope it's clear by this point. And then now the baby gets born. And then the baby now needs to adapt to a new way of the body, actually the heart, the body needs to adapt to a new way of transporting blood, because remember, two things actually happen. Two important things happen when the baby gets born. The first thing is that the cord is what? It's cut. So meaning the baby is disconnected from the what? From the placenta. The placenta is no longer a primary source of blood and nutrient and the like. The baby, because the cord gets cut. And then the other thing is that the baby takes its first breath, initiating its own respiratory system and ventilation. So the baby takes its first breath. So what happens is this: when the baby gets its first inspiration, its first breath, the lungs are going to expand. Remember, inside the uterus, the lungs were collapsed, but now the baby takes in its first breath, the lungs are going to expand. So what is going to happen is that the blood which was coming here, it's no longer much of the blood is going from the pulmonary artery into the aorta via the ductus arteriosus. But now the thing is that the lungs, and why we want much of the blood to pass through the ductus arteriosus is because we don't want much of the blood to go to the lungs, because the lungs are collapsed, they're not functional while the baby, in the fetus rather. But now the baby is breathing, the lungs are functional. So we would actually want much of the blood to go to the lungs so that they can, and the blood, they can be gaseous exchange, because remember, the cord has been cut, meaning the baby is no longer receiving any oxygenated blood anywhere else. So the lungs need to begin to function in order to supply the blood with more oxygen. So much of the blood is actually going to go to the lungs, right? Much of the blood is going to go to the lungs, from the lungs, pulmonary vein, from the pulmonary vein, the left atrium, the left ventricle. From the left ventricle, the blood goes to the aorta. But remember, there is the ductus arteriosus. It is still parted in this case, but the ductus arteriosus is actually sensitive to three things. The first thing is that the ductus arteriosus, and once the blood, remember, it is oxygenated, because the blood went via the lungs, gets oxygenated, more oxygenated, and then it goes to the left atrium, then to the left ventricle, then it goes to the aorta. But here there's a shunt, so some of the oxygenated blood will actually go via down the ductus arteriosus. But the ductus arteriosus is actually what's sensitive to three things. One, it is sensitive to oxygen. So what happens is that when the blood which is highly oxygenated, is passing through this ductus arteriosus, because the blood is highly oxygenated, and this ductus arteriosus is sensitive to oxygenated blood, it tends to shrink. So that's the first thing that causes it to shrink, the high oxygenated blood, or the presence of oxygen. And then the other thing is that once when the blood goes to the lungs here, there's a substance that mixes with the blood. There's a substance that mixes with the blood known as the bradykinin. So the bradykinin, again, the ductus arteriosus is sensitive to this substance. So because the blood is passing through here and then through the ductus arteriosus, and then not only is it containing oxygen, but it's also containing a substance that the ductus arteriosus is highly sensitive to. And this substance is what we're calling as the bradykinin. So the bradykinin also will lead to the ductus arteriosus to get constricted. And then the third thing is that the cells of the ductus arteriosus, they tend to produce prostaglandin in the absence of oxygen, right? Yes. So the prostaglandin, what it does is that it keeps the ductus arteriosus patent. Right now, there's blood that is passing through this opening, and this blood is highly oxygenated, meaning the cells of the ductus arteriosus will no longer produce prostaglandin, because it only produces prostaglandin in the absence of oxygen. But there is a presence of oxygen, which means the production of prostaglandin is going to reduce. So what is going to happen is that the production of prostaglandin is going to reduce. Therefore, it will no longer keep the ductus arteriosus patent. So these three things are going to lead to the constriction of the ductus arteriosus. So the ductus arteriosus is going to shut down. It's going to get closed. Yes. So that's what after some time, that's what happens. It's going to shut down. It's going to get closed because of these three things it's actually sensitive to. Yes. And then what happens is that the blood that is coming, because remember, the cord has been cut, so little amount of blood is actually coming in the right atrium, but we've got more blood coming in the left atrium, because more blood is going to the lungs than to the right atrium. So we've got a higher blood pressure in the left atrium, and we've got low blood pressure in the right atrium, because it's no longer receiving much of the blood. The cord has been cut, so there's a difference in the pressure. The left atrium has got a higher pressure than the right atrium. So there is an opening here, a shunt, which we're calling the foramen of veil. So because of the difference in pressure, this is what leads to the closing of the foramen of veil, because there's little blood coming in the right atrium and there's more blood coming in the left atrium. So this leads to the closing of the foramen of veil, and the ductus venosus also closes up. So the main there are five changes that are actually happening after birth. One, there is a constriction of the arteries, the umbilical arteries. Then there's constriction of the what? Of the umbilical vein. Then there's there's the closing down of the ductus venosus. There is the constriction rather of the ductus venosus, there's a constriction of the foramen ovale, and there is a constriction of the ductus arteriosus. These so that the body can undertake its normal circulatory system. And then you have to know that if these shunts remain open, you find that now the baby is going to have congenital problems. For example, if the ductus arteriosus remains patent, this is what the baby is having, a congenital condition known as patent ductus arteriosus. So the main changes, so those are the five changes that will happen after the baby gets born. One, the umbilical arteries gets constricted, the umbilical vein gets constricted, the ductus arteriosus constricts, the foramen ovale constricts, and the ductus arteriosus also tend to constrict. So when these constrict, there is now a new way the baby there's now a new way the blood is flowing in the body. So so this is how it's going to. So now we're talking about the postnatal blood circulation. So blood from the inferior vena cava and blood from the superior vena cava, it is going to go in the what? In the right atrium. From the right atrium, it won't go to the left atrium because the shunt here has been what? Closed. So it is actually going to go to the right ventricle. From the right ventricle, it is going to go through the pulmonary artery. It won't go via the ductus venosus arteriosus rather, because the ductus arteriosus has actually been constricted. And then from the pulmonary artery, it's going to go to the lungs. Why? Because now the lungs are fully functional and the alveoli fully functional. Gaseous exchange can actually take place there. So in the lungs, the blood, this blood exchange of this gaseous exchange, then blood will go via the pulmonary vein into the left atrium rather. From the left atrium, blood goes to the left ventricle. From the left ventricle, blood goes to the aorta, then the rest part of the body. So that is the postnatal circulation. And then if we can go any further, you would find that these remnants that are no longer needed by the body, they tend to turn into ligaments, but we're actually just going to end here. So like I said, the normal fetal circulation is from the placenta via the umbilical vein to the liver. From the liver, the blood goes into the inferior vena cava via the ductus venosus. From the inferior vena cava, the blood goes to the right atrium. From the right atrium, blood goes to the left atrium via the foramen ovale. From the left atrium, blood goes to the left ventricle. From the left ventricle, blood goes to the aorta. Then blood coming from the superior vena cava goes to the right atrium. From the right atrium, blood goes to the right ventricle. From the left ventricle, blood goes to the pulmonary artery. From the pulmonary artery, much of the blood will go to the aorta via the ductus arteriosus. The little amount of this blood will go to the liver via the pulmonary artery. From the lungs, blood is going to go to the left atrium via the pulmonary vein. Then blood will go to the left ventricle. From the left ventricle, blood will then go to the aorta. Then blood will go down to descend in the aorta, then back to the umbilical arteries, then back to the placenta. So that is how blood is moving. After birth, the umbilical arteries constrict, the umbilical vein constricts, the ductus venosus constricts, the foramen ovale, they constrict, they close up. The ductus arteriosus also closes up. Then blood will now start moving from the inferior vena cava and the superior vena cava. Blood comes in the right atrium. From the right atrium, blood goes to the right ventricle. From the right ventricle, blood goes to the pulmonary artery, then to the lungs, then to the pulmonary vein, then to the left atrium, then to the left ventricle, then to the aorta, then to the rest part of the body. So that is how blood is actually moving. Then this is actually just talking about the same things that it's highlighting what I was just explaining on the diagram. So during pregnancy, the fetal circulatory system works differently than after birth. The fetus is connected by the umbilical cord to the placenta. This is the organ that develops and implants in the mother's uterus during pregnancy. Through the blood vessels in the umbilical cord, the fetus gets all the needed nutrition and oxygen. The fetus gets life support from the mother through the placenta. The waste products and carbon dioxide from the fetus are sent back through the umbilical cord and placenta to the mother's circulatory system to be removed. The fetal circulatory system has 3 shunts, which we talked about: the ductus arteriosus, the foramen ovale, and the ductus venosus. These are small passages that direct blood that needs to be oxygenated. The purpose of this shunt is to bypass the lungs and the liver, as these organs are not fully working until birth, so they're still going under development. The shunt that bypasses the lungs is called the foramen ovale. This shunt moves blood from the right atrium of the heart to the left atrium. The ductus arteriosus moves blood from the pulmonary artery to the aorta. Oxygen and nutrients from the mother's blood are sent across the placenta to the fetus. The enriched blood flows through the umbilical cord to the liver and splits into 3 branches. The blood then reaches the inferior vena cava. This is the vein connected to the heart. Most of this blood is sent through the ductus venosus. This is also a shunt that lets highly oxygenated blood bypass the liver to the inferior vena cava and then to the right atrium of the heart, just like we said. A small amount of this blood goes straight to the liver to give it the oxygen and nutrients it needs for its development. Waste products from the fetal blood are transferred back across the placenta to the mother's blood. So what happens inside the fetal heart? Blood enters the right atrium. This is the chamber of the upper right side of the heart. Then blood enters the right atrium. Most of it flows through the foramen ovale into the left atrium. Blood then passes into the left ventricle. This is the lower part of the chamber. Blood then passes to the aorta. This is a large artery from the heart. From the aorta, blood is sent to the heart muscle itself and to the brain for their development as well. After circulating there, the blood returns to the right atrium of the heart through the superior vena cava. Very little of this less oxygenated blood mixes with the oxygenated blood. Instead of going back through the foramen ovale, it goes into the right ventricle, like we said. The less oxygenated blood is pumped from the right ventricle to the pulmonary artery. A small amount of blood continues on to the lungs. Most of this blood is shunted through the ductus arteriosus to the what? To the descending aorta. This blood then enters the umbilical arteries and flows to the placenta. In the placenta, carbon dioxide and waste products are released into the mother's circulatory system. Oxygen and nutrients from the mother's blood are released into the fetus blood. After birth, the umbilical cord is clamped and the baby no longer gets oxygen and nutrients from the mother via the placenta. With the first breath of life, the lungs start to expand and the alveoli in the lungs are cleared of fluid. An increase in the baby's blood pressure and a major reduction in the pulmonary pressure reduces the need of the ductus arteriosus, to shunt blood. These changes help the shunt close. The changes raise the pressure in the left atrium of the heart. They also lower the pressure in the right atrium. The shift in pressure stimulates the foramen ovale to close, like we stated earlier. The pressure of the ductus arteriosus, ductus venosus, and the foramen ovale completes the change of fetal circulation to the newborn circulation. So that marks the end of today's lesson. I hope it has enlightened you, and I hope you may be able, it is going to actually make your studies easier. So like I said, this is Miss Kanyambu from Grace Nutrition Center, and thank you so much for being here with us, for going through with us with this lesson. So see you.